We added loops, breaks, and condition to our programming language, our interpreter, in the last video, and we have come quite far. The only thing left in the interpreter is adding support for functions, resolving and binding, which is an intermediate step between parsing and interpretation. We'll add another class, resolver, that will do something for us. We'll get to what it does soon. And then we have classes. And subsequently we have inheritance of these classes. There are essentially three things remaining. And it will take me about 4 to 5 videos to complete functions. And this is going to be the first video that we will handle functions. Anyways, in this stage, as you know, we need to add support for functions but in this video, we'll only handle native functions for now. Native functions are functions that are built into your language. You do not need to define them as an end user. They're just available to be used. Uh, an example is the clock method. This clock function will give you the current time. It returns the number of seconds elapsed since this date, and the return type can be a floating point number or an integer. Since it's possible that the thing being called is not a function, what I mean is, it's possible that we can call an expression. In languages like JavaScript, functions are first member methods of the programming language, first level members, sorry. And it's possible that our expression results in a function call. More importantly, a function call can result in another function call. Like, let's suppose this is function, then it may return a function so that we can call another function. We can change these function calls. So it's possible that the thing being called is not necessarily a function. It may be a function call that we can call. So because the function may return another function, or it can be another expression that results to a function, or it may result to another function, maybe a ternary. And depending on the condition, we call different functions. Function A, it returns function A if true, otherwise it returns function B. And it's possible that we call this. Alright? So an expression can also result in a function. Therefore, we should separate the function calls and function definitions in the grammar itself. We're not handling function definitions, but for native functions, we definitely need to handle function calls. Uh, Also, we need different syntax to call functions and different to define them. When we're defining them, the things in the parentheses are called parameters, and when we're calling functions, the things in the parentheses are called arguments. So a function call will have arguments and a function definition will have parameters. And then we need to match the arguments with the parameters. Since in logs, when you define functions, you don't define data types, right? It's a loosey-goosey language. We don't define data types, so we don't have to do any pattern matching based on the types of parameters, but we definitely need to check the number of parameters. What I mean to say is, let's say this is a function. This is a built-in function and it has 2 parameters. So and it's called clock, as they say. It's a built-in function. Let's say it has 2 parameters. It doesn't, but let's say. So when the user calls it, when somebody uses this function, they're going to pass it some parameters. Param1, comma, param2. When executing a function call, we need to check if the parameters are matching or not. And since there are no data types, all we can do is check that the number of parameters matches the number of parameters in its definition. So when we come to function call, we will count these number of parameters and we will match them with the number defined in the function definition. They want us to add the clock native function, but we will also add another native function and it will be quite useful. We'll add something called read line, and read line function will allow you to accept a line in the console from the user. It will read input. It's like scanner.next line, sc.next line in that case. So read line will be interesting to add. It will take input from the user. And since functions in this program are first level members, they have to be high in precedence. It's essentially even more high precedence than a unary expression, because if we were to write yeah. If we were to write this, then the function call is executed first, and then the return of the function a is negated. So it's even higher in precedence than a unary expression. So we need to update the CFG to handle all of our requirements. Let's do that. This is what our current context free grammar looks like. Let me copy it. Need to add functions to it. Functions. Like I told you, function calls are even higher in precedence than a unary. Therefore, they must be added right here because they're higher in precedence. So call. Now this call is, what does a function call look like? It's an identifier for the function followed by opening and closing parentheses, and inside of these parentheses we may have arguments. So we may have an identifier, that is the name of the function, then opening and closing parentheses, and then some args. So now this may not necessarily be an identifier. It can be a primary, uh, because primary handles identifier for us. So we'll just add primary, and we already have a method defined for primary. So it will handle the identifiers for us. Then we have opening and closing parentheses, right? And opening and closing parentheses. And inside of these opening and closing parentheses, we may have some arguments. And these arguments are optional actually. We don't need them. And as I told you, we can chain function calls. Now this name function may return a function which can be called, and so on. So these functions can be nested, and we've been handling nesting with this regex. So what do the arguments look like? Arguments is going to be an argument, would be any expression, because when we're calling a function, what I mean is, let's say clock takes a number, I can pass it 2 plus 3. 2 plus 3. It takes, if it were to take an integer argument, we can pass it an expression and that will be evaluated. So arguments should be expression, and these expressions are separated by commas. So comma, and then if there is a comma, there must be another expression as well, and we can have 0 or 1 of expressions. So this, if there is argument, there must necessarily be an expression, and argument itself is being used as an optional. So if we don't parse arguments, then we have 0 expressions. But if we parse arguments, then there necessarily must be one expression. That's what this rule says. So we added a new AST node in the grammar, so we should add it to our AST as well. Since it's an expression, I'll create it right here, and it must extend, you guessed it, expression, and we should implement the methods, and we should visitor.visit call expression, and we should call it with this. Let's create this method. Since we create this method, we should also update the AST printer. The AST printer, I'll just copy the code for the AST printer. It's quite simple. Call.callie. So, it's not there yet. Wait. So we need to implement this method. But before that, we should decide what's going to be there in this call class. If you were to look at the context-free grammar, you'll realize that we have an expression for the primary. The identifier, it's going to be an expression, and then we have arguments, which is a list of expressions, and we need a token where we will store this opening parentheses so that we can point to it if in case there is an error. So we need 3 parameters: public final expression callee, public final token parentheses. We need this because token has a line, right? Line number. So we need this to point to the function call in case there is a parse error. So we'll use this token to point to it, tell the line number to the end user. And then a public final list of expression, which will be the arguments of the method. And we should create a constructor for these. All right, argue arguments. So now finally in the AST printer, let me just copy it. The callee is the the identifier. So this will resolve the identifier, and I'm just printing the function call as is. That's it for the AST printer. We need to close this. We can close this and close this. So we added the call. The callee will serve like a variable lookup in the env. So when we define a function, we will add it to our env, and this callee expression will resolve to an identifier, and that identifier can be looked up from the hash map. That's what we want. The thing that will be retrieved from the hash map must be something that can be called, not a variable value, right? So we will do that by uh, adding it to our hash map when we initialize the interpreter. But what do we add? The thing we want to add will be a locks callable, will be a subchild of a class that can be called, right? So we will create this locks callable, but we'll do it later. I'll show you what it means later, but let's now implement the parser to parse the call method. If you were to look at the context-free grammar, we updated the unary. So let's look for it in the parser. So here it is. So in our unary, previously we were looking for a primary, but now we're going to look for a call. And we need to create that call method. That's how we've been doing it so far. So let's do that. Instead of primary, here is the primary, we will call a call and the rule is updated as well. Let's create this method. And in this call, let's bring in the rule from the context-free grammar. What does the rule look like? Here is the rule. And so the first thing we need to parse is a primary. So let's do that. Expression expr is equals to primary. That is done. Then the next thing we need to parse is a list of arguments, but before that we must consume an opening parentheses. So, and if in case there is no opening parentheses, then it's not a call, it's just an identifier, right? So let's create an empty list of expressions that will serve as the arguments. So we will keep on parsing it. See, like I told you, function calls can be chained. So it may be possible that there may be multiple of these opening and closing braces. So we need to parse them all. So we will keep on parsing them while true. And if we match an opening parentheses, match current token left parentheses, in that case I will check if the next token is a right parentheses. If it is, then arguments is 0, right? But if it's not, then there are some arguments that need to be passed. So if not check current type to be a right parentheses, in that case we need to parse some arguments, right? Arguments. And after parsing those arguments, I will get the token. There should be a right parentheses that should be consumed. So consume, and it consumes a right parentheses. And let me throw in the error. Now we can finally create a object of call, and inside of this call it expects the expression, the arguments, and the in that order. No, I think the order is fucked up. Parent, arguments, I guess in that order. So that will keep on parsing the left and right parentheses for us. But in case we do not match a left parentheses, in that case we can break out of this while loop. And it's a call expression. There will be no end semicolon that needs to be consumed. And finally, you can return the expression. We need to create this method as well that will help us parse the arguments. Just a helper method. So it will return a list of expressions, and it will be called. When it will be called, we won't have read the right parentheses. We've just checked it. So we should create an empty list of arguments here as well. And control will only come here if the current token is not a right parentheses. If it were, the control would not have come here. So we can start parsing the arguments. It's going to be an expression necessarily, and I can simply add it to our arguments. Arguments dot add arg, and while there are commas according to the grammar, let me bring in the grammar. While I see commas, I will keep on parsing expressions because there may be more. So while we match the current token to be a comma, you can keep parsing arguments dot add expression. Now there is something that you will find if you were to read the book. This points to a book, right? So if you were to read the book, you will find something that the creator of the language Lox has implemented a constraint on the language, that is any method can only take 255 arguments. So if arguments dot size is greater than equal to 255, in that case we need to throw an error because more arguments are not allowed. So report peak, there is can't have more than 255 arguments. That's the error. And from here we can finally return the arguments. That's it for the parser. Uh, we have updated the AST printer. So now, like I told you, we need to add something to our env at the time of initialization of the interpreter. We need to add the implementation of the clock method. What I'll do is I will create an interface, logs callable, and then I create a clock class, and that class must implement the logs callable interface. So only the things that implement the logs callable interface will be allowed to be called, and it will include things like classes because we need to call classes to create their objects. So let's create that logs interpreter. Uh, Sorry, logs callable. What I'll do is alongside of this expressions statements, I'll create another package called functions. And inside of that functions, I'll create a new interface called logs callable. And it's going to be interface. This interface will be required, but what does it contain? It will contain a single method called call, and it will take an interpreter and a list of arguments, and the arguments may be of any type, so object. Now if you have ever seen a functional interface in Java, then this interface will be quite similar to you, will look quite similar to you. It's essentially doing the same thing for us. It's like a functional interface for us. The other thing that this functional interface needs to have is something called arity. Now this arity is used to determine how many arguments it has. So if you go to Excalidraw, I told you, right, if for every function call we need to match the defined arguments with the number of arguments. This defined argument is called arity. So we need to check arity against the size of this list of arguments in the concrete implementation. So they need us to implement a clock class, so we will do that. And this clock class must implement logs callable. Let's implement the methods, and I will also add a toString to it. So it's just a native function. That's the toString, and it has an arity of 0. The clock method, the clock function doesn't take any arguments. And what it does is it typecasts it typecasts the system.current time in milliseconds to double and divided by 1000 because we need to return seconds. If you were to read the instructions, they want us to return the number of seconds elapsed since this, and this method in Java does the same thing for us. So we'll use it. That's the clock class. The next thing is that they don't ask you to do, but I want to do is add a read line class, and it must also implement the clock interface. Sorry, logs callable interface. So let's implement the methods and arity, and it will have the same toString methods. It also will have an arity of 0, and we will create an object of scanner and use it. New scanner system dot in, and this will be used to take user from input from user, return sc dot next line. Similarly, you can add other methods to our language that will read int or read next token for you, and you can use the scanner class to implement it. Now finally we can add objects of this clock and read line to our interpreter. So let's go to it. We will do that by creating a constructor for it first. We do not have a constructor, right? So let's create the constructor public interpreter. And so the thing of with function calls is it will be used later on, not for this, so we'll do it later maybe. env dot define for clock. I will define a new uh, object of clock, and for read line I will define now the functions are defined. I can use them in a function call. I can look for them and you call the dot call method on them. So let's go to the and implement the visit call expression. Inside of this visit call expression, I need to resolve the callee. That will be the primary, that will be the identifier. So object callee equal to call dot callee dot accept. That's the beautiful thing about the visitor pattern. And this accept will also, since it's a primary, it will also resolve it from a variable lookup, and this will be equal to an object of clock or a read line. So if it is something else, then we need to throw an error. If not callee instance of logs callable, in that case we need to throw an error. Throw new interpreter exception, and inside of that exception the error will be can only call this. Let me copy it. That's the error we need to throw. Then there are going to be a list of arguments. Now the list of arguments have been expressions, and those expressions need to be evaluated as well. So I will evaluate them in a loop and then add them to this arguments list. For expression arg in call dot arguments dot add arg dot accept of this, and finally logs callable the function. I will typecast it. I'll typecast the callee to logs callable, and we need to throw an error if the function dot arity does not match, uh, is not equal to the size of arguments dot size. In that case also we need to throw an error. Let me copy the error. This will be the error. Expected this many arguments but got this many arguments instead. And finally we can call the function dot call method, and this call takes an interpreter and the arguments. Why the interpreter? I'll show you later on. uh, it's so that the function call, see the function call, right now we are doing native functions, but later on we need to have user defined functions, and user defined functions may have expressions in them, statements in them, and those expressions and statements need to be evaluated. So this interpreter will be used to evaluate them. What's the error? Yeah, we need to also return it. Okay, so I think this will be working now. Let me try it in test.logs. Print clock. Does it work? So we got something. And what about read level? Does that work? It does. There is something that I need to change about. Instead of println, it's just going to be print. Now let's try to finally commit and push it. Native functions. Alright, so it does work. And we can move on to the next stage, that is user defined functions without, oh, I think we'll pass this as well. Is this just function with arguments? Let me see, I'm just exploring. User defined functions, no. So we can finally move on to user defined functions from the next video. I guess that's it for this one. See you in the next video.